Hi, this is your cheat sheet on kinematics. Kinematics is where we describe motion with equations and graphs, studying our world and how things move. We're going to be going over position, displacement, distance, scalar and vector quantities, velocity, acceleration, average velocity, systems, and reference frames. Got that? Good. Let's go. Kinematics starts with position, which is just where an object is relative to a fixed point. So let's just say we got Jimmy here. He's going to be our demonstrator and he's chilling on the number line. To find his position, we first look at where 0 is, which is our fixed point. And we compare his location in relation to that 0. If we were to graph this, it would be a straight line because Jimmy's lazy. So as time progresses, Jimmy's position stays the same. He stays at 30. Now position can change and you can measure it in two different ways. You can take its displacement and you can take its distance. Displacement is how far an object is from its original position. Like I said before, the X signifies position, and the I subscript here means initial, so we're looking at the initial position here. Displacement is a vector quantity. Vector quantities have a value, or in this case an amount traveled, and a direction. By a value, I mean like 1, 2, 3, 4, 5, and we signify the direction usually with a positive or a negative. You can see here positive means that the object is going to the right, and a negative means that the object is going to the left. Don't confuse these with regular negative numbers or positive numbers, because although our arithmetic will be dealing with that kind, the actual value, if it is negative or positive, doesn't really mean it in the traditional sense. It's talking about the direction. And in some physics word problems, the direction might also be specified using cardinal directions, as in north, east, west, south. Distance is just how much the object has traveled, and it's a scalar quantity, which is just a value. It's just 1, 2, 3, 4, 5. The difference between the two is that distance takes into account every position change. Displacement is just how much the position has changed after all the traveling is over and the journey has ended. And you specify displacement with a direction, because like I said before, it's a vector quantity. Let's take a good look at an example. Here, Jimmy decides to go and meet Timmy. How nice. And then walk back to his house, which is his final position. He goes 3 whole miles to see Timmy. Damn. And 2 miles back to his house. Now the distance here would be that Jimmy has gone 5 miles in total, because like I said before, distance is the total journey. So you add the journey from here, the initial position, to Timmy, and then the journey back to his house. The displacement is the difference of Jimmy's final position minus his initial position. So if he starts at 0 miles, goes 3 miles to see Timmy and 2 miles back, that means that the final position is 1 mile away from Jimmy's initial. Plugging those in gives us a displacement of 1 mile east. We could have also put a positive just plus 1 mile. But to even go anywhere, like what Jimmy did to go see Timmy, we need to get a car. So Jimmy gets a car. Good job, Jimmy. Now when you think of car, you gotta think about speed. You probably already know what speed is. Speed is just how fast an object moves. And it's a scalar value, meaning it doesn't have any direction associated with it. I mean, you don't hear about like negative 50 miles per hour. No, you hear about regular 15 miles per hour. But we don't deal with speed that much because we talk more about velocity. Velocity is basically just speed with direction. Textbook definition would be that velocity is the rate of change in the position with time, always in meters per second, or usually meters per second. Simple terms, it means how fast or slow something is going, and the direction it's going. See, that's the difference between speed and velocity. Because like displacement, velocity is a vector quantity. You calculate velocity by dividing the change in position over time. If we were to graph this, you can see that velocity is actually the slope of the position over time, where velocity is staying constant here at 2. If we were to calculate the slope of this line, you would find that it is 2. Just a interesting connection, and will come up later. Velocity can also change, which changes the rate at which Jimmy moves. As you can see here, velocity doubles at the 10-second mark, and so Jimmy becomes quicker, becomes faster. And like I stated before, velocity is a vector quantity. So when it's negative, it doesn't mean that it's like going down, it means it's going to the left. So at the 10-second mark where it changes, Jimmy goes all the way to 10 meters, and then back the other direction, and his displacement ends up at 0 because he's back where he started. Let's go back to when our boy Jimmy got a car. You probably heard about the acceleration of a car. Acceleration is the rate of change in velocity over time. Or, in simple terms, it basically means how much something speeds up or slows down. The same relationship position has with velocity is the same relationship that velocity has with acceleration. It sounds a little confusing, but we'll get to that later. Acceleration, like velocity, is a vector quantity and can be expressed in meters per second squared. You find it by dividing the change in velocity over the change in time. If we were to graph this, you can see that just like position and velocity, the slope of velocity would be acceleration. And in most problems that you will encounter, acceleration stays constant. And just to show you how position changes as velocity changes at a constant rate, since velocity has acceleration making it increase, the object is accelerating faster and faster, faster. An important thing to note is that the area here underneath acceleration gives you the velocity, and the area underneath velocity gives you the position. That sounds weird, but let's take an example. Let's just take this point. At this point in time, 10 seconds, how much is velocity? I mean, we can see it here, but don't mind about that. This area would be length times width. So if we were to draw a rectangle, our length would be 2 and our width would be 10. Multiplying these together gives us an area of 20 meters per second. As you can see here at the 10-second mark, velocity is 20 meters per second. It's pretty intuitive, but if you want, I have this table that explains some scenarios of different slopes and velocity and acceleration. Remember, the positive and the negatives don't mean that it's higher or lower, it means the direction. So, if velocity was positive and acceleration was also positive, velocity is making the position go to the right, and acceleration is adding onto that velocity, making it speed up. Since there's a negative here, it doesn't mean it's slowing down. It means that it's going to the left. And acceleration is boosting velocity, making it speed up to the left. Here's the opposite. Velocity is positive, meaning it's moving to the right, but acceleration is decreasing it. Acceleration is making it go to the left, meaning it's slowing down. The same here. To find the average velocity, it's easy. Just take the change in position over change in time. This equation here works for if velocity is constant at constant values or increasing at a certain rate. However, there's another equation you can use. But this is only when acceleration is present and velocity is increasing at a constant or decreasing at a constant rate. If acceleration isn't 0, or if acceleration is constant, you use this equation. The one from before is applicable to every case, but if this comes up, this equation here, it's pretty handy to have. Some extra info on these two equations. This here kind of resembles how you would normally calculate an average. You would take the two ends and then divide it by 2. The amount of data points you have and then divided by the number of data points that you have. However, this only works for when velocity is constant the whole time or velocity is increasing at a constant rate. Let me explain. These two velocities aren't made equal. v2 goes on for longer than v1, meaning that the object goes for a faster speed for longer. Velocity isn't constant here. There's 2 values for velocity, and there's no constant increase. So using the normal average here and just substituting velocity 1 and velocity 2 wouldn't make sense. This kind of implies that you're treating both velocities as equal, even though velocity 2 kind of takes the stage and drives the change in position for longer. This is why instead of finding the average of the different velocity points, we find the average by taking total change in position over change in time, which basically is just averaging out the line and then figuring out velocity from there. Weird? It's a little weird, I understand. But that's just how it works. Finally, let's talk about how we would even observe things like position, velocity, and acceleration. This is what we call an inertial reference frame, which is basically just a point of view where we observe motion. While Jimmy is doing his thing, we watch and take note of whatever he's doing. We consider each object, or objects in correlation with each other, as its own system. This word will come up a lot. A system is just the set of objects that we observe as the reference frame. It can be as simple as a single object, or as complicated as multiple objects interacting with each other. An inertial reference frame either stays in place and remains at rest, or is moving at a constant velocity, but it never accelerates. Both scenarios, the objects move in relation with each other. Both of these are going at the same constant velocity, and so both will observe that Jimmy isn't moving. But that's because the reference frame is moving at the same speed as Jimmy. So that's why both of these would record the same thing. Now, in contrast, a non-inertial reference frame would be one that is accelerating, but we won't talk about that. Now, here are most of the equations that you're going to need for this unit. You can see x is position, v is velocity, a is acceleration, and t is time. The subscript I here means initial, and f means final. So in this case, this here would be saying the final velocity. This would be talking about the initial velocity. I suggest searching up on Google if you want to find more equations, talk with your teacher, know what you have to use. And sometimes, instead of putting I as the subscript, a 0 is used. But the 0 and I mean the same thing, the initial position, or initial velocity. Alright, that's it for 1D kinematics. Now get out of here and ace your next kinematics test.